Let's discuss one more problem related to proving the triangles congruent. Let's start. In the given figure, we have the figure line L is the bisector of angle AOB. Okay, angle AOB and L should be the bisector. So let's write over here that this is the bisector. Bisector, very important word. Bisector, it is divided into two equal parts. Now angle bisector means what? It is going to divide these two angles into two equal parts. Remember these keywords, these are very important. These are the conditions, hidden conditions that we need to identify. Angle bisector divides angle into two equal parts. Let's read further of angle AOB. D is a point on L. So D is the point on the line L. Now DL perpendicular OA. So DL perpendicular OA, this 90-degree condition written in the words. Then DM perpendicular OB. So what we need to prove? We need to prove that triangle OMD congruent triangle OLD. So we need to prove these two triangles congruent. That's the first condition. Next is DM is equal to DL. Okay, that can be done because why? It's very easy. We just need to write CPCT and we can write DM is equal to DL. So our main target is to prove the first condition, which is two triangles are congruent. Let's start. So first of all, list out the conditions. This is interesting question. So here let's write S, A, S, then A, S, A, and AAS and RHS. Okay. So in these two triangles, there is a one angle, 90-degree, right angle. So most of the time, students start thinking about the RHS. Whatever you do, just prove it with the RHS and you are done, right? Don't have that approach. No, that's a like inverse approach you have it. First of all, start what do you have over here. Then you choose, right? What I mean by this, it's not compulsory that 90-degree means always RHS or 90-degree means you are not supposed to use RHS. It depends on the given condition. That's what I mean over here. So first of all, let's write L, okay, is the angle bisector of angle AOB. So what we can write? Okay, so this angle and this angle is equal. So let's write angle AOD, angle AOD is equal to angle BOD, angle BOD, right? Because it is angle bisector. OD is the angle bisector, you can take it. Done. Is there anything else is given? Yes, we have the 90-degree angle. So let's write angle OLD, angle OLD, angle OMD. OMD is equal to what? 90-degree. Right angle, perpendicular it is. Okay, that being done. So if you observe, we have two angles over here. So SSS we cannot take, SAS as well, ASA might be, or AAS might be, RHS. Okay. Now RHS, if you observe, one right angle, hypotenuse and side. So basically two side you should be having it. We don't have, right? And I told you sides either it is given in the question itself, or it will be common, or some conditions given over here. Here we don't have any conditions, so let's try to take with the common sides. So when we talk about this upper triangle, let me draw over here. It is what? OLD, right? This is 90 and here, okay, this is ODM. So this angle and this angle is equal so far, right? This angle and this one, right? Two angles we have it. Now let's talk about this side. So see over here, I told you common side. Let's think about the common side. See, OD is common in both of them. See, right? Now first of all, think, is it ASA or AAS? See, what kind of condition do we have? Angle, angle, and here it is side, right? So I told you in AAS, side will be in touch with only one angle. only one angle, not included like the previous one. Previously we had included one. So same goes over here, angle, angle, and side over here, right? So side is in contact with this angle DOM and DOL, right? So this is the AAS criterion, remember, right? Because side is only in contact with one angle. So let's write OD is equal to OD, and here common side, right? Done. So let's write, okay, we have already written AAS. So angle, angle, and this is side. So let's write by AAS criterion, by AAS criterion, we can write triangle. What we need to prove? OMD and OLD. So OMD congruent triangle OLD, right? So first condition is done. Very simple it was. Now second, DM is equal to DL, DM is equal to DM, right? This is what we need to prove it. So this is very simply can be done by the CPCT. So CPCT, we can directly write DM is equal to DL, right? You can even write OL is equal to OM. It depends, right? So this was very interesting question because people do think that it is RHS, but it's not, right? I don't mean that every right angle will not be the RHS, but you focus on the condition which is given over here. One is the angle bisector, means two angles are equal. You can see over here. Then another 90 degree. So two angles we have. We were confused between these two. Then we thought about this side. No condition for the sides were given in the question, but there was chances of common side and we thought in that way. And finally, we come to know that OD is the common side between these two triangles. So angle, angle, side, and this side is in contact with only one angle. So that's why we are concluding as AAS. So by AAS, we can write this triangle and this triangle is congruent, and by CPCT, we can write DM is equal to DL. So this is how we solve this sum with the help of AAS criterion. Let's start with one more question. We have the figure in the question. It is similar to previous one. Let's start with the question. In the given figure, if AD is equal to AB is equal to 3 cm and AC is equal to 5 cm, show that triangle ABC congruent triangle ADC and BC is equal to CD. This is similar to the previous question that we discussed, right? We need to prove two triangles congruent and we need to prove one more condition based on the given triangle. So first of all, let's list out the conditions that we have it. First of all, we have AD is equal to AB. So AD is equal to AB is equal to 3 centimeter, right? That being done, we have 90 degree here, right? Very interesting. So let's write angle ABC is equal to angle ADC is equal to 90 degree. That also done. Now one more condition is given, AC. So let's write AC is equal to AC. And what can we write over here? Make sure that we can write common side between these two triangles. Okay, I'll explain if you are still confused. First of all, let's list down the condition. SSS, SAS, then we had ASA, then AAS, and finally the RHS. Okay, so 90 degree means we can guess that it will be RHS. Previously with the 90 degree we had AAS, right? So think of the RHS for a while if it is possible based on the conditions, not like RHS. Okay, so first of all, right angle, we have it. Now first of all, let me draw this over here. So yes, this will be 90 degree. It's okay, assume it is 90 degree. ABC, here we have this, right, and this as equal. So when we talk of the RHS criterion, we know there should be one right angle that we have over here, then hypotenuse. Now hypotenuse is always opposite to 90 degree. Remember that very well, right? So opposite to 90 degree is what? AC. So we have hypotenuse as well. And side, I told you, you can have any side, maybe base or maybe height as well. So in this case, we have the base, right? I mean kind of height as well, or any side you can say for the understanding. That's better. So we can use RHS over here. Let me write you in a proper way so you can understand that how it is RHS. So first of all, right angle. So let's start with the right angle. We have angle ABC is equal to angle ADC is equal to 90 degree. Then hypotenuse. I'm still telling you hypotenuse is opposite to 90 degree. So if we talk about triangle ABC, hypotenuse is AC, opposite to 90 degree. And if we talk about triangle ADC, opposite to 90 degrees again AC. So we can write AC is equal to AC, right? The reason is common side. Or you can also write that AC is equal to AC, value is also same. Then let's write about this side. So which side is there? Now this angle is done, this hypotenuse is done. Now whatever is left is your side. So AB is equal to AD. Let's write here that AB is equal to AD is equal to 3 centimeter. So we can write by RHS criterion triangle, right? Which are the two triangle? ABC congruent triangle ADC. Done. Now we need to prove one more condition over here. That's very simple, you know very well. BC is equal to CD, BC is equal to CD. That we are going to write by the CPCT. So by CPCT, corresponding part of congruent triangles are equal. That will be, we can write BC is equal to DC. Very simple question. The purpose of doing this question is how we can use the AAS and RHS based on the given condition. Always remember, don't have the illusion 90 degree means always RHS, right? Previously with this same case, right, we had the AAS because conditions were different. Remember, conditions matters a lot. Here we have already given that AC is 5 centimeter, okay, common side, even though we would have taken it, and AD and AB is equal to 3 centimeter, right? And 90 degrees also given over here. So we have one angle and two sides, and one angle is 90 degree. So we were thinking that it can be RHS, right? So I did not filter much over here because right angle was there. So I was like, let me try to take it. Previously we tried as well, but it was not working, right? So here write for the right angle, then hypotenuse and side. Remember, hypotenuse is always opposite to 90 degree. When we talk about the normal right angle triangle, you can get very easily. But when this kind of figures are there, you always need to identify which is the hypotenuse. And if you are confused, it will be difficult to reach the proper conclusion, right? Opposite to 90 degrees is always your hypotenuse. That being done, so by RHS criterion, prove that these two triangles are congruent, and by CPCT we can write whatever condition which is asked in the question. So this is how we do the sum based on the RHS criterion.